Okay, then we've got this awkward looking equation here. We've got fractions of quarters, fifths and twelfths. Now if we want to scale this fraction up, because we can scale up the equation to get something so that all these fractions disappear. Now the 4 and 5, the lowest common multiple of that is 20. So if I times this by 20 both sides, these two fractions would basically vanish if I scale up by 20. But if I scale this up this side by 20, the 12 wouldn't vanish. So 20 is not suitable to times by. So if I look at these three things, if I notice that goes into 20, but that also goes into 60, which is also what 12 goes into. So if I times by 60 all the way through, so I'm scaling up this equation by 60. So 60 of these, of the first object, plus 60 of the second object, more than one term put a bracket. You always do that when you're doing. So 60 lots of these plus 60 lots of these equals, and then we do 60 lots of these. And you should see by scaling it up by that multiple, then all these awkward fractions will cancel out now. This will be 15, won't it? 5 goes into 60, 12. And 12 goes into 60 5 times. So what have we got? We've got 15x here. 12, 2 lines, remember? 1 line, 2. So 12 times 2 is 24. So that's plus 24x. Minus 12, 1's a 12 with a minus, equals, and 5 7's are 35, so that's 35 lots of x. So I'm going to move this 24 now. Oh, 15 and 24 is 39x minus 12, so I've collected the x's here, equals 35x. So that's a bit more user friendly now, isn't it? Let's move this 35 over to be with the 39. When you move it across equals, it flips the sign, so it becomes a minus. And let's move the minus 12 through the equals to become a plus 12. 39 take 35 is 4, so it's 4 lots of x, equals 12. And then lastly what we need to do is move the 4 from times down to divide. 12 over 4, which is equal to 3. So let's just check if that's correct then. We could tap it in the calculator because we're saying that 3 lots of 3 quarters plus 3 in here, 6 minus 1 is 5, so 5 over 5 is 1. And then 3 in here, 7 3s are 21 over 12. 21 over 12, is that correct? Well, if you divide this fraction by 4's top and bottom, you get 3's top and bottom. You get 7 over 4, don't you? And, oh, this was a 5. I wrote 1 for some reason, because it was equal to 1. So you got 3 quarters plus 1, that's 7 quarters when you do fractions. So you can tap that in a calculator if you need to, just to check with the x value of 3 that this is actually correct. So yeah, just done a little double check there in the margin. So we know that's checked and is correct. So what did we do? We looked for what we call the lowest common multiple of all these three numbers. We worked out that it was 60. So 60 of these, 60 of these, and 60 of these. We'll get rid of everything underneath in terms of the fractions. So 60 of these, the 4 goes into 60, 15. And 60 of this lot, 5 goes into 60 12 times. So it's just 12 at the top. And then 60 of these, 7 over 12, the 12 goes into 65 times, so then just tidy it up. Move the x's over to the side, the same side, which we did when we added them up. We moved it over, and we moved the numbers over to the other side and flipped the signs. Then we just tidied up, collected the terms of the x's, and then moved from times on one side to divide on the other. And that's it, x equals 3.